Alright, so number 13, again, you have to do stuff with geometry. That means you have to draw the Lewis dot structures. So, PCl3, the first one. I know that P is probably going to be my central atom, and I'm going to have 3 Cl atoms around it. That is my skeleton. Now I have to find the number of valence electrons. So P in the periodic table is in this group, so it's going to have 5 valence electrons. And Cl, again, is in this last group right here, so it's going to have 7 valence electrons. But I have 3 of them, 1, 2, 3, so I have to multiply that by 3, and that's 21. 21 plus 5 is a total of 26 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. If I look at that geometry chart thing, I have 3 bonded stuff. So 3 bonded stuff and 1 lone pair. So 3 bonded stuff and 1 lone pair. That is a pyramidal, also known as a trigonal pyramidal. So this one is actually correct. So that one looks like a pretty good answer for shape correctly matched to the geometry. Let's look at B and D. OF2. O is probably my central atom. F are probably around it. Oxygen is in group 6A, so it's going to have 6 valence electrons. Fluorine is in group 7A, so it's going to have 7 valence electrons. And there's 2, so I have to multiply that by 2 to equal 14 plus 6, 20 valence electrons. So I have to draw 20 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All of my atoms are happy with 8 valence electrons. And now I can go to my chart and see that I have 2 bonded pairs, somewhere one of these, and I have 2 pairs of lone electrons, of lone pairs. So I have 2 bonded pairs and 2 lone pairs. So 2 and 2 is a non-linear, but this one is saying that it is linear, but I know it is a non-linear, so this one is wrong. Last but not least, SF6. S is probably my central atom, and I'm going to have a total of 6 fluorine atoms coming out of it. I know that this breaks the octet rule for sulfur, but sulfur is one of those atoms that can handle more than 8. So just by looking at this, I really don't need to figure out how many valence electrons are going to be in this thing, because I know that my sulfur cannot hold any more lone pairs. So it already has 6 things around it. That's like maximum Lewis dot structure right there. So something that has 6 bonding pairs and no lone pairs is called an octahedral, and that is saying that this is a tetrahedral, so this is wrong. So my answer is A.